To grasp the scientific merit of the four pathways, we must for the moment leave this philosophic construct and consider them purely from the nature of energy. Matter and energy are the constituents of all tangibility, and either can be transformed into or thought of in the context of the other. Energy exists as a range of frequency values that begins with the lowest in sound, 0 Hz being silence, and continues to the highest in light, where electromagnetic radiation takes it to 2.4 times 10 to the 23rd Hertz. That's a 1 followed by 23 zeros, or 10 multiplied by itself 22 times. Hertz refers to cycles per second. Once a range of values has been established for any quantity, in this case a frequency, the ability to subdivide it into smaller ranges of values for that quantity exists. This applies, of course, only for tangible quantities to which arithmetic processes can be performed. For instance, both infinity and zero would be excluded, since neither can be subdivided or multiplied. And the concept of quantity in the subatomic world, where things can pop in and out of tangibility from nowhere, and existence itself is often only theoretical, is abstract at best. But for quantifiable tangibility, this ability is true even when a range of values isn't obvious. As an example, it is easy to imagine a ruler with 12 inches being divided into 4 equal segments, 1 to 3, 4 to 6, 7 to 9, and 10 to 12 inches respectively. But what about a solid object or non-segmented quantity, say an apple pie or glass of orange juice? Using 4 again as our divider, the juice and pie can be visualized as being split into 4 equal quantities. But it is less obvious that the slices of pie represent the circumferential portions of the whole pie in degrees from 1 to 90, 91 to 180, 181 to 270, 271 to 360. Or that the smaller glasses of juice contain the 1 to 25, 26 to 50, 51 to 75, 76 to 100 percentages of liquid in the original glass from top to bottom. In these cases, equal has been thought of in a linear sense. Linear in mathematics means of or relating to a class of polynomial of the form y equals ax plus b, definition courtesy of Wiktionary. Used generally to plot xy coordinates, it can be applied to our previous subdivisions. X is the whole quantity, A is the proportion of the whole being subdivided, and Y is the subdivision, B equals 0. Regardless of specific inches, degrees, or ounces, quantitatively, all subdivisions in each case are equivalent. But mathematics allows us also to consider equal in a logarithmic sense. What's that? Perhaps the clearest illustrative example is found in music. Examine the keyboard of a piano. The pattern of white and black keys consistently repeat, with 12 total pitches in each octave. That is a linear subdivision. And yet the frequency doubles from a given note in one octave to the same note in the next. Such a relationship is logarithmic. For instance, the pitches of the note A over a 7-octave span are 55, 110, 220, 440, 880, 1760, 3520, and 7040, which is the start of the next octave. In each case, the pitch of that note has doubled from the previous. The equation for this sequence is f sub n equals 2 to the n minus 1 power times capital F sub n equals 1, where f is the frequency of an octave n of a fundamental capital F. Mathematically speaking, each octave begins at the nth value of capital F. F equals capital F when n equals 1, since any number to the 0 power is 1, that is, F equals 1 times capital F. For the above sequence, capital F is 55. The logarithm of a number is the exponent or power by which another fixed value called the base is raised to yield that number. In our equation, the base is 2, its logarithm is n minus 1. The exponent for octave evolution from a specific root frequency, capital F. 2 to the n minus 1 power is itself the sequence 1, 2, 4, 8, etc., the evolution of all even numbers that are solely multiples of the prime of 2. From them can be determined the proportion between any two frequencies in the evolution of octaves, irrespective of root. To illustrate, from the second to third and third to fourth octaves, the frequency has doubled. 4 divided by 2 equals 8 divided by 4 equals 2. From the second to fourth, it is quadrupled. 8 divided by 2 equals 4. The value of a fundamental has no effect on the proportion between the frequency values of its octaves, only on the values of the frequencies themselves. The difference between linear and logarithmic subdivision is that in the latter, the proportion in subsequent subdivisions are exponential. How does this then apply to the frequency range covered by light and sound? As our music example has shown, linear and logarithmic subdivision can be simultaneously occurring. But it is the logarithmic that is particularly revealing in allowing us to see the relationship light has to sound in the theory of harmonic creation. It occurs through harmonic evolution. Given a highest value for light, a value x can be found such that the sequence 1, x, x to the second power, x to the third power, and x to the fourth power is satisfied, with x to the fourth power equivalent to that highest value. 1 is included since we want to subdivide into 4 ranges the complete electromagnetic spectrum, which, for our purposes, 1 Hz to x to the 4 Hz will satisfy. The ranges are 1 to x to x second power, x second power to x third power, and x third power to x fourth power. This sequence itself follows from the previous equation for the specific case where the fundamental and the base are the same. X is the common value. By the law of exponents, f sub n equals x to the n minus 1 power times x to the first power, which equals x to the n minus 1 plus 1, which equals x to the n power. Now, n specifies the number of the range. X to the n minus 1 determines the proportion between any two frequencies. Capital F, the first frequency range, is x to the first power. Mathematically, each range ends at the nth value of x. The first 4 values of n, 1, 2, 3, 4, will establish the frequency ranges of the 4 pathways. For simplicity, if we allow a maximum value of 10 to the 24 Hz for electromagnetic radiation, that sequence is 1, 10 to the 6, 10 to the 12, 10 to the 18, and 10 to the 24 Hz. X equals 10 to the 6. Establishing its value was easily done by observation, which may be a reflection of the simplicity of this fundamental truth to light itself. Logarithmic solutions would allow this process to be applied to divide any frequency range into 4 or whatever number of harmonically related ranges. Still, how is this subdivision relevant to sound, with its highest humanly audible frequency being around 20,000 Hz? In the above sequence, it is a small portion of the low end of the first range. The relevance occurs through the process of further levels, which provides for additional logarithmic subdivisions until you arrive at the one containing only the octaves of our piano. And since the principle of further levels mandates that each level exists in the context of all those before, a correspondence between the frequencies of light and sound exists. This is in the same way that each A on our piano could be considered the pitch A and yet be a different frequency. There are A's throughout the electromagnetic spectrum, so even the highest light frequencies can be translated into sound, which, as we'll later see, has significant repercussions. That answers energy having 4 frequency ranges. But can't there be 3 or 5 as previously queried? Absolutely. And the harmonic evolution of prime numbers allows that to occur to infinity. But 4 is important because it is the lowest harmonic subdivision that can provide for the tangible universe to exist. And this is a truth so significant that it has been represented in the teachings of some of the most revered and respected religious founders and scientific leaders to have ever blessed this planet with their presence. Next up, Part 3, in religion.